Here we're going to do a couple examples to wrap up section 5.3. So first of all, we have one that says, given that cosine theta equals 1/2 and sine is less than 0, find the value of sine theta and secant theta. Now, what we want to do with a question like this is locate the angle theta on in the coordinate plane, and more precisely on the unit circle. So cosine, it says cosine is equal to 1/2. Well, cosine has a value equal to 1/2 when theta is equal to pi over 3 and at pi over, or 5 pi over 3. And these values are just coming from the unit circle. What I'm doing is I'm saying, well, cosine, if cosine is equal to 1/2, that corresponds to the x-coordinate. So what I'm doing is I'm thinking, where on the unit circle, what angle has an x-coordinate that is equal to 1/2? And those two angles are pi over 3 and 5 pi over 3. I could have also done this in degrees. This is equal to 60 degrees. This is equal to 300 degrees. So if I were to draw a unit circle, 60 degrees is somewhere up here, 300 degrees somewhere down here. And again, I could work in radians. I could label the 60 as pi over 3 or 300 as 5 pi over 3. It doesn't really matter for this question. There's nothing in the question that tells us to use radians or degrees. Now the second piece of information, it says that sine theta is less than 0. Well, what this is saying is sine is negative. Because sine is negative whenever we are in quadrant 3 and quadrant 4, that tells us that the angle that we are concerned with must be this angle down here, because that's the only place out of these two possibilities that's the only angle that is negative. So theta must be equal to 300 degrees or 5 pi over 3. Now the whole reason I went through this process is because I need to determine which quadrant theta is in, and theta is in quadrant 4. So what I'm going to do is I'm going to draw a triangle in quadrant 4 with theta as the central angle. Okay, and what it's saying is cosine is equal to 1/2. Well, if cosine is equal to 1/2, cosine is always x over r. So the r value is the hypotenuse here, and x is 1. So what I need to do is I need to figure out this y value. Once I figure out this y value, I can determine what sine of theta is and what secant of theta is. Well, I don't actually even need the secant or the y value to determine what secant is, because secant is just equal to 1 over cosine theta. We already know what cosine theta is. It's 1/2. So secant theta is equal to the reciprocal of cosine. So that's just 2 over 1 or 2. So secant is equal to 2. Now, to determine what sine is, well, sine, one way we can think of that is opposite over the hypotenuse. Now, in this triangle that we have here, this is going to be opposite over the hypotenuse. So we must figure out what that y value is. To determine what the y value is, we're going to use the Pythagorean theorem. So y squared plus 1 squared equals 2 squared. So y squared is equal, or I should say, plus 1 equals 4. Y squared equals 3. So y is equal to plus or minus square root 3. Now, because we're because this is below the x-axis, that y value must be negative. So I'm only going to use the negative value of the square root. So what that's telling us is sine theta is equal to, that y value is equal to negative root 3 over 2. Now, we could have done this directly from the unit circle, because we know on the unit circle at 300 degrees, the coordinates of that point there are positive 1/2, negative root 3 over 2. So the sine value is this negative 3 over 2 over 1. So right off the bat, if we know the unit circle, we don't have to go through all of this second part of the problem with the triangle. However, if we don't recognize that 1/2 is a coordinate on the unit circle, going through this process might be helpful. Okay, here we have one that's very similar. Tangent theta is equal to 3/2. Well, tangent is positive in the first quadrant and the third quadrant. So what that's telling us is this 3/2, theta must be in either quadrant 1 or quadrant 3. Now out of those two quadrants, which one has a cosine value that is negative? Well, cosine corresponds to the x-coordinate. The x-coordinates are going to be negative in quadrant 3. So tangent is positive in quadrant 1 or quadrant 3. Cosine is negative in quadrant 2 or quadrant 3. So the overlap here tells us that our desired angle theta is in quadrant 3. So I can just draw a triangle like this. Theta is always the central angle. A common mistake that students make here is they draw the triangle like this. Now the triangle, that angle theta always makes an angle with the x-axis. So don't draw the triangle in this way. We want to draw it in this way. So, okay, so there's our angle theta. And then what we're going to do is use this fact that tangent theta is equal to 3/2. The ratio for tangent is opposite over adjacent. Remember, so TOA. So TOA is opposite and adjacent. So opposite here is going to be 3 and 2. So we need to figure out this R value. And in fact, we have negative values here because that's an x coordinate here, and that's negative, and similarly this is negative y coordinate. So what we're going to do to find R, we use the Pythagorean theorem. And doing so, we get plus or minus square root 13. Now when we're talking about the hypotenuse in a triangle like this, we always use the positive value of the square root. So once we have the triangle, finding sine and secant of that angle, not a big deal. So sine is equal to opposite over hypotenuse. So the opposite side of theta is -3. The hypotenuse is square root 13. We just need to rationalize, and we get -3 root 13 over 13 here. Similarly for secant, well, secant is the reciprocal of cosine, so 1 over cosine theta. Well, cosine is adjacent over hypotenuse, so let's figure out the cosine value and then we can just take the reciprocal. So cosine is adjacent over hypotenuse. Well, if we want to take the reciprocal of that, we're going to say that secant theta is equal to square root 13 over -2, and we have it. All right, we have one more question like this. We have a tangent value that is negative. Well, tangent is negative in quadrant 2, quadrant 4. And sine, what this is saying is sine is positive. Sine is positive, well, sine corresponds to the y-coordinate. Y is positive in quadrant 1 and 2. Oops, 1 and 2. So the overlap there is quadrant 2. So we're going to draw this angle theta in quadrant 2. So again, draw the triangle using theta with the x-axis here. So right triangle, and then it says tangent is -4/5. So tangent is opposite over adjacent. Now which one of these is going to be negative? Well, because we're in quadrant 2, x is always negative, y is always positive. So the x-coordinate here will be negative, the y-coordinate is positive. Then what we need to do is find the r value. Again, use the Pythagorean theorem, and we end up with square root of 41. And then from there, we can find the 5 other trig values for theta. So again, SOHCAHTOA. Sine is opposite over hypotenuse, so that's going to be 4 over square root 41 times square root 41 over square root 41. We get 4 square root 41 over 41. For cosine, that's going to be adjacent over square root 41. And rationalizing, we get negative 5 square root 41 over 41. Cotangent is just the reciprocal of tangent, so that's going to be negative 5/4. Secant is the reciprocal of cosine, so the reciprocal of cosine, let's use that first version. We have negative square root 41 over 5, and then cosecant is the reciprocal of sine. We get positive square root 41 over 4. And the last item to discuss is a reference angle, and a reference angle is the acute angle formed with the terminal side of an angle and the x-axis. So suppose we have this angle here and this angle here. The reference angle, or that ray, those two rays form an angle. So theta in here is our angle. Now, in this particular one, the reference angle is the angle formed between the terminal side. Well, this is the terminal side, and the x-axis. Well, there's the x-axis. So this actually right here is the reference angle. Now, when we're in the first quadrant, reference angles are pretty easy to see. If this is our angle, well, the angle is going to look like this. There's theta. But the reference angle is this angle right here, the angle between the terminal side and the x-axis. So this, actually I don't want to put x there, let's call that beta. So beta would be the reference angle. So suppose angle theta, let's say that equals 200 degrees. Now beta is the angle that's just between that terminal side and the x-axis there. So beta is going to be, well, to get back to this position here, this distance right here, we know that that's 180 degrees. So beta is just the distance between 180 degrees and the finishing up of the angle theta. So that is a reference angle of 20 degrees. So 20 degrees would be the reference angle there. Now, one thing we need to remember is that reference angles are always positive. Okay, so no matter what the angle we're looking at, if we want the reference angle to that angle, we're always going to have a positive value. So let's actually find some reference angles here. The first one, we have 240 degrees. So 240 degrees, it's a little bit beyond halfway around the circle, because we know halfway is 180 degrees. So the reference angle is this angle right in here. And that distance, let's call that theta. So theta here is going to be 60 degrees, just 240 minus 180. So 60 would be the reference angle for this first. The second one, 2 pi over 3. Well, we know that 2 pi over 3 is in the second quadrant, and 2 pi over 3 is on the unit circle, so that also helps us see where this is. Now the reference angle is going to be whatever gets us back to the x-axis as quick as possible. So theta is going to be the reference angle there. And we know that halfway around the circle is pi. So that reference angle is going to be pi minus 2 pi over 3. This is 3 pi over 3. It's going to be a reference angle of pi over 3. 900 is a little bit different because it's more than one revolution around the circle. So 900 is 360, so one time around the circle, plus 360, that gets us to 720, so plus 180. So 900 is going to be 360, 720, 180. So this angle is in this direction. Now, because this angle is right on the x-axis, the reference angle, to get back to the x-axis, well, there is no distance that we need to travel to get to the x-axis. So what we'd say is the reference angle theta is actually equal to 0 degrees. If we wanted to do that in radians, well, we're starting in degrees, so typically we write that reference angle also in degrees. And then lastly, negative 13 pi over 6. Well, that's one time around the circle, but because the angle is negative, we're going in the clockwise direction. So this would be negative 2 pi, or negative 12 pi over 6, and then a little bit more to get us that extra pi over 6. So there's the original angle. Now the reference angle is just going to be right here. So that distance right there is theta is going to equal pi over 6. And again, remember, reference angles are always positive. So reference angles are really helpful when we are working on the unit circle. So I have 5 different angles on this unit circle. What I'm going to do is I'm going to label the coordinates for each of these angles. So at pi over 6, I have pi over 6 has coordinates of root 3 over 2 and 1/2. Now, remember, in the first quadrant, the x-coordinate is positive and the y-coordinate is positive. And that's what we have here, positive root 3 over 2, positive 1/2. Now, in quadrant 2, x is negative, y is positive. So what that means is the coordinates for this point are the exact same, root 3 over 2, 1/2. The only difference now is that the x-coordinate is negative. Okay, so what we need to realize is that when we see this angle 5 pi over 6, what we can think is, oh, that has a reference angle. This distance right here is the same as this distance right here. So if we see an angle that's 5 pi over 6, the reference angle there is pi over 6. Now, once we realize what the reference angle is, once we realize that the reference angle is pi over 6, we can recall that these are the coordinates for that reference angle. And then the only thing that we need to do differently is figure out if the signs change based on what the coordinate is. So 7 pi over 6, well, that has a reference angle, again, pi over 6. So I look over here at pi over 6. What are the coordinates? The coordinates are root 3 over 2 and 1/2. And then I just need to realize that x is always negative, y is always negative in quadrant number 3. So this is going to be negative root 3 over 2, negative 1/2. And then lastly, 11 pi over 6, that reference angle is pi over 6. Pi over 6 has coordinates root 3 over 2 and 1/2. So what that means is the coordinates here are going to be root 3 over 2, 1/2. When we are in quadrant number 4, x is positive, y is negative. So what that means is x is positive, y is negative. So this is maybe a quick way or a helpful way to use reference angles in the unit circle. If you are able to remember what happens in the first quadrant with those angles and the coordinates, we can, no matter where we are, we can use what's in the first quadrant to figure out the coordinates. We'll do one more example here. So let's say we're at 240. Well, 240, that reference angle is this angle right here. And we know that that's 180 degrees. So that reference angle is 60. Well, 60 degrees in quadrant 1 gets us to this point right here. And the coordinates of that point are 1/2 and positive root 3 over 2. So 240 has the same reference angle as what's happening right here. So the coordinates are the same, 1/2 root 3 over 2. The only difference is the signs. Because I'm in quadrant 3, both coordinates have a negative sign.